working on this week. By the way, I enjoyed watching all your videos on your egg drops. Anyway, enjoyed seeing you guys do that. You guys did a great job. So for your paper, the requirements are in the document that's attached, but just want to refresh because it's been a while since you've done some calcs. First thing you do is an energy analysis. You need to calculate the kinetic energy at the top before you drop the egg. And the formula for kinetic energy is here. Velocity is 0, so it has no kinetic energy. You're holding it still. You'll calculate the potential energy by taking the mass. Remember, the mass of your apparatus, it's going to be estimated. Assume the egg weighs 57 grams. You need to convert that to kilograms. G is 9.8. And then the height you'll need to measure in meters or estimate in meters. So that'll be your potential energy before you drop the egg. Now remember, as you drop the egg, all of that potential energy, it's transformed into kinetic energy. So it goes faster and faster and faster as it falls until it hits the ground. So at the bottom, all of your potential energy at the top is converted into kinetic energy. And then the potential energy at the bottom, like right before it hits the height is 0, so the potential is 0. So the potential transforms into kinetic energy. And remember, the units for energy are joules. So that's the energy analysis. So make sure that you clearly show your formulas and what your measurements are that you're plugging into these. Then to calculate how fast the egg's going just as it hits the ground, use your kinetic energy right at the bottom to calculate your velocity, which solve for V, 2 times kinetic energy divided by the mass. Remember, mass is in kilograms. And that's going to give you the speed in meters per second that the egg is traveling right before it hits. And then last but not least, you need to calculate the force that the egg experiences upon impact. The easiest, you might be thinking F equals ma, which would work. We need to calculate the acceleration. The easiest way to calculate that force is to use the impulse momentum equation, where impulse is force times the time that that force is applied, equals the change in momentum. And I've rearranged this a little bit because it's the same object, but it's going to be the mass times the final minus the initial velocity. Now, solve that for force, and we know the mass of your apparatus. You know the final velocity is 0. You know the initial velocity. This is like as the egg hits. The initial velocity is going to be the velocity like right before the egg hits, and then it stops. This happens over a very, very small period of time. You're going to need to estimate this time that it takes the egg to slow down. Now, if I just drop an egg and it splats on the ground, this is going to be like 0.001 seconds, which makes the force really big, which breaks the egg. If your apparatus protected the egg, it most likely increased this time to maybe 0.1 seconds or 0.05 seconds, where the force that the egg experienced was less than it took to break it. So that's a quick, maybe not so quick, but a refresher in the calculations that you guys will need to turn in your energy analysis.